5235. Propeller efficiency is the A. Ratio of thrust horsepower to brake horsepower. B. Actual distance of propeller advances in 1 revolution. C. Ratio of geometric pitch to effective pitch. The correct answer is A. Propeller efficiency is defined as the ratio of thrust horsepower to brake horsepower. Thrust horsepower refers to the power generated by the propeller in producing thrust, which is the force that moves the aircraft forward. Brake horsepower, on the other hand, refers to the power delivered by the engine to the propeller. The efficiency of a propeller is a measure of how effectively it converts the power supplied by the engine into useful thrust. A higher propeller efficiency means that a larger portion of the engine's power is being used to generate thrust, resulting in more effective propulsion. 5236. A fixed-pitch propeller is designed for best efficiency only at a given combination of A. Altitude and RPM. B. Airspeed and RPM. C. Airspeed and altitude. The correct answer is B. A fixed-pitch propeller is designed to operate at its best efficiency at a specific combination of airspeed and RPM, engine revolutions per minute. The specific combination is determined during the design and manufacturing process of the propeller. The efficiency of a propeller is influenced by various factors, including the speed at which the aircraft is flying, airspeed, and the rotational speed of the propeller, RPM. The design of a fixed-pitch propeller is optimized to achieve its best efficiency at a particular combination of these two variables. 5237. The reason for variations in geometric pitch, twisting, along a propeller blade is that it A. Permits a relatively constant angle of incidence along its length when in cruising flight. B. Prevents the portion of the blade near the hub from stalling during cruising flight. C. Permits a relatively constant angle of attack along its length when in cruising flight. The correct answer is C. The reason for variations in geometric pitch, twisting, along a propeller blade is to maintain a relatively constant angle of attack along its length when in cruising flight. The angle of attack refers to the angle at which the relative wind hits the propeller blade. As an aircraft moves through the air at different speeds, the relative wind changes, and the angle of attack on the propeller blade may vary. To ensure optimal performance, the propeller blade is designed with a varying geometric pitch along its length. This means that the pitch angle of the blade changes gradually from the hub to the tip. By having a twisted or variable geometric pitch, the propeller blade can maintain a relatively constant angle of attack along its length during cruising flight. This helps to optimize the propeller's efficiency and minimize drag, resulting in improved performance. 5654. To establish a climb after takeoff in an aircraft equipped with a constant speed propeller, the output of the engine is reduced to climb power by decreasing manifold pressure and A. Increasing RPM by decreasing propeller blade angle. B. Decreasing RPM by decreasing propeller blade angle. C. Decreasing RPM by increasing propeller blade angle. The correct answer is C. To get the most power for takeoff, a low-pitch, high RPM setup is used. Once the aircraft is in the air, an increased blade angle or pitch will result in a decrease in RPM, which will produce enough thrust and improve economy by keeping the right velocity. 5667. To develop maximum power and thrust, a constant speed propeller should be set to a blade angle that will produce A. Large angle of attack and low RPM. B. Small angle of attack and high RPM. C. Large angle of attack and high RPM. The correct answer is B. A constant speed propeller is designed to allow the pilot to adjust the blade angle, also known as the pitch, to optimize engine performance. In order to develop maximum power and thrust, the propeller should be set to a small angle of attack and high RPM, revolutions per minute. By setting the propeller to a small angle of attack, the blades present a smaller surface area to the oncoming airflow. This reduces drag and allows the engine to produce more power, resulting in increased thrust. Additionally, setting the propeller to a high RPM ensures that the engine is operating at its peak power output. This provides the maximum amount of energy to the propeller, which translates into greater thrust.